So the task for this assignment was to use the balsa wood given and a few weeks to have all that we learned applied in a small glider that needed to be able to fly at least 20 feet. Following are the contents that we will be talking about. The glider must be hand thrown, so no pilot, no propeller. The glider also has to fit in a box that's 16 by 16 inches. The vehicle has to remain intact for the flight, so it has to be structurally sound. The vehicle should be primarily made from the balsa wood that we were provided. So there's a stability trade-off because balsa wood can be weak and it has to be structurally sound, so that means sturdy. It has to fly for at least 20 feet and only the vertical distance will be counted. So as to have good enough balance so there's no pitch or yaw motion. So we were instructed to use balsa wood, but the cons of it is that it's weak and it can break, but it's lightweight. We could have also used 3D printed parts or made designs for the laser cutter, but I was pressed for time and had not taken engineering graphics. So I did all of the designs and the final product by hand with an X-Acto knife using primarily balsa wood and Play-Doh for balance and the center of gravity. Adhesives, we had wood glue and super glue. Wood glue was made for wood, but actually terrible on its own, and it kept falling apart while it was being built. Super glue was a lot better. It dried faster, but on its own, it was still also terrible, so I had to use both. The aspect that I made the most iterations to was the wing shape. At first, I chose a rectangular shape because it was the easiest to construct. There was too much induced drag, so there's a tiny replica instead of a full-size example because the wings actually broke. Tapered was the second iteration, which was basically like the tiny glider. It was meant to reduce drag, but I didn't like the way it flew, so I decided to stick with the elliptical design, which was best because the induced drag is tested to be the lowest according to research. And I used a slight dihedral angle, which I originally avoided because it'd be hard to construct, but it maximizes lift, so I used it in the final design. Some of the flights. My final design right there, minus the added mass. There's some designs for the tail configuration. Everything stayed the same except for the wing design and the wing placement. More will be discussed. So originally I planned to just scale up the dimensions of the small glider by a factor of 2, so it would go from 8 inches to 16, but I learned that the fuselage had to be 70% of the wingspan, so it was like about 11 inches. That's what it ended up being. The research also showed horizontal wing should be 20 to 25 of the wing area, so it did end up being like that, 12, which did not change from my original plan. Research also recommended the vertical tail to be about 50% of the horizontal tail area, so that stayed the same with my original design too. Balance and stability was another thing that was a problem. So it started going to one side. So one of the mentors gave me a small piece of mass to attach to one of the wings on the dihedral. So it ended up flying a lot more stable than before. We were also told that the center of gravity had to be quarter cord length. So I added enough Play-Doh for that to happen. And those were my final iterations. And I also had to move the wings back because it kept flying around and not having the optimum center of gravity. Some of my flights were not recorded since it was an individual project, but come test day, it still ended up being the distance required. So for the calculations of the result, we were given 2 equations, one for the coefficient of lift and one for the coefficient of drag. And if you notice from my work, all of the values in the equations are quite small, but that's because I converted it to feet. So all of the inches, everything was converted to feet. So I would have like one unit to worry about. My coefficient of lift was 0.67 and for drag it was 0.34, which reflected the way it flew in the test flight. So it actually flew the correct amount of distance, but unfortunately it did not fly as much as it did before because of how large the coefficient of drag was. Other reasons that it could have affected the way it flew this time rather than my previous test flights is because of the way I threw it, which I learned that had a lot of effect on how it flew, and all of the wind that was present that day. As my glider broke in half before the final flight, I had to fix it before. Here are some sources I used to help. And that's all. Thank you.